Welcome to the Spy Collection Digital Edition, where we are looking at spy artifacts that only exist in digital format. It's been a long time since we looked at an artifact from Edward Snowden's leaks, so in this episode we'll have a look at this presentation, the Introduction to Virtual Private Networks Exploitation Process from September 13, 2010. Apparently this is over a decade old, and we can safely assume that the United States National Security Agency has gone under various restructurings since then. However, this is a unique piece of history in the SIGINT world that even to this day it provides a glimpse into this lesser-known cyber espionage world. Just like in our previous episodes, we have reconstructed the slide deck to a widescreen format and by adding transitions to make it easier to navigate and talk over it. What we have is a presentation that the OTP, that is, the Office of Target Pursuit, was doing to SIGINT analysts of the NSA to brief them into what their VPN exploitation team could offer in case they ever needed their services. Before we go there, a quick overview of virtual private networks. Nowadays, most people think that VPNs are to hide your IP address, but that's literally a side effect, not the reason for their existence. Normally, if we have network A and want to talk with network B, and particularly back in 2010, all unencrypted communications can be intercepted as long as the attacker, the NSA in this case, had access to some of the internet infrastructure those communications were going through. Check our presentation on the Prism and Upstream for more details on that passive collection capability. For this reason, VPNs were invented in 1996 so that you first establish a secure encrypted channel between two nodes and then you use that to access each other's networks. Even today, most organizations use VPN to allow their workforce to work remotely and access resources inside their organization's networks. The side effect is that if you try to access the internet, you could be exiting from a node of network B in this example. But that's a side effect of the VPN technology. It could be configured differently too, but that's out of scope for this presentation. That said, let's go back to the leaked slide deck. This was the agenda of this presentation, so don't worry about it. We'll cover each and every slide in detail. The NSA is a huge organization, and going to a team level is typically not productive for historical research purposes since it can get overwhelming. Here we're reading that the S31176 is a specific NSA branch, the custom thread development for network encryption. And that presentation was performed by members of the VPN exploitation team, which was part of that branch. Don't worry about the numbering scheme, we'll get back to it shortly. The mission of this team was to provide cryptanalytic support services for many network encryption protocols, including but not limited to IPsec, SSL, PPTP, SSH, and proprietary protocols. It continues that we are the front door of cryptanalysis and exploitation services for targeted vulnerability assessment and custom interim end-to-end exploitation flows for these protocols. In conjunction with various agency SIGDEV counterparts and target organizations, we engage in discovery to find TOPI targets of interest. By maintaining contact with field sites, TAO and NCSC, we endeavor to guide and direct development and access through both active and passive means in order to make exploitation possible and enable full prosecution of the target. Quite a few buzzwords here. So, IPsec, SSL, PPTP, and SSH are different technologies widely used at the time for VPN and VPN-like secure communications. Next, SIGDEV stands for Signals Development and are experts in their domain, in this case encrypted communications, that can dive deep into a type of signal and its infrastructure to develop new methods to extract information from it. Then TOPI was standing for Target Office of Primary Interest. NSA had numerous different TOPIs with different focus areas. Let's say Russia, nuclear weapons, Iran, etc. TOPI analysts were the ones receiving all the intercepted communications for their area and were performing analysis and production of intelligence reports. Lastly, the mission statement says that the team was working with both TAO, Tailored Access Operations, and the NCSC. This mission statement is telling us that the VPN exploitation team were the experts of the NSA if someone within the NSA's SIGINT organization wanted to spy into VPN and VPN-like communications but doesn't have the ability to do so. They were in touch with both their hackers and their defenders to keep up with their current landscape and constantly looking to provide more access to their analysts working on specific domains. In summary, they were acting as the one-stop shop for all the network encryption exploitation related issues, as a liaison for signal developers and topics to other areas of the VPN community, and also perform signals development and target discovery. We mentioned not to worry about the numbers because this presentation explains it perfectly. S stands for Signals Intelligence Directorate, the largest directorate of the NSA. In C, the part responsible for gathering data was the S3, or as it was called, Data Acquisition. In S3, we find the CES. As its name implies, CES was focusing mainly on encrypted communications and how to take advantage of them. Part of S31 is the office we're looking at, the OTP, Office of Target Pursuit, with quite a descriptive name. Inside this office, it was the Cryptanalytic Exploitation and Discovery, which was having teams that were looking into how to spy on encrypted communications. And this is where the Custom Threat Development for Network Encryption branch was under. And inside this branch was the VPN exploitation team that was doing this presentation. The next redacted slide had the contact details for the different key stakeholders of this branch, as well as their internal website. Now that you probably understand better the numbering system and naming schemes at the NSA in 2010, you probably wonder why this branch ends with 6 instead of 1. What happened to the other 5 branches under the Office of Target Pursuit? Well, the presenter was kind enough to let us know. The first one was focusing on targets from China, North Korea, Southeast Asia, and Japan. The second one was going after targets related to Iran, Hamas, Iraq, and Saudi Arabia. The third one looking at Africa, Levant, Latin America, India, Pakistan, and Afghanistan. The fourth was going after Russia, counterintelligence, Europe, as well as what the NSA called FTM, or follow the money. The fifth branch was for cross-target support, and the sixth is the branch that was doing this presentation that we're looking at today. Moving next, as we're reading, each OTP branch had a VPN representative from the VPN exploitation team that informs them about attacks, and they inform them about targets using VPN technologies. Then in this slide there was a list of contacts of those VPN exploitation team representatives, which was apparently redacted to protect those individuals. Basically, if someone in any of those branches ended up with a target that was related to VPN technologies that they couldn't spy on, they could reach out to the representative from the VPN exploitation team, and that representative will help them achieve that. And of course, the other way around. If the VPN exploitation team managed to hack into a target falling under the responsibilities of any of those branches, that representative will share with them this new intelligence collection source. So what exactly did the VPN exploitation team offer to the NSA? As we're reading, they were providing exploitation support in order to find VPN vulnerabilities. The second one was to engage network security products, tailored access operation, exploitation solutions office, and others. This basically means that the VPN exploitation team was acting as the subject matter experts on VPN exploitation for all of the different teams in the NSA Signals Intelligence Directorate. Third, convey meaningful feedback to customer. Once again, as the experts in their domain, they could provide accurate assessments and feedback about VPN exploitation solutions. Fourth, develop sustained exploitation threads when possible. Fifth, suggest alternative approaches if passive exploitation is unrealistic. Passive exploitation in this context means that the VPN exploitation team didn't have to work with the tailored access operations to hack into those devices, but more take the VPN traffic that was captured passively without any sort of active exploitation and try to decrypt that. So if this was unrealistic, they were the ones that can provide alternative solutions in order to get access to the encrypted communications. And finally, decrypts, which shows us the emphasis of this team into getting encrypted VPN traffic and decrypting it so that the intelligence analysts can use it. But the team wasn't limited just to that. As we're reading in the next slide, additional services, they were also assisting with collection problems. For instance, a non-VPN expert might not know that there are other means to get the same information that an analyst might need. Tasking, prioritizing which targets to go after first. Data flow refers to providing analytic products that show how communication flows from point A to point B. Plain text analysis refers to analyzing unencrypted network traffic to extract valuable information from that. Metadata interpretation is once again from all of the captured traffic. Instead of looking at the content, look at all of the metadata around it. For instance, even in VPN communications, you can still see who is the source, who is the destination, the time of communication, sometimes the volume of communication, the software and hardware being used, and other similar metadata. Tip of vulnerable VPN links. This means that the team could monitor specific VPN links, and once they were able to identify vulnerability, notify the right stakeholders that now they are able to access this previously secure communication channel. Virtual private network signals development was also explained in a previous slide, is developing new methods for signals intelligence on VPN technologies. And lastly, target discovery and development, which again goes back to the slide about helping other branches and TOPIs, not only as the VPN experts but also identifying targets in their domain using VPN and proceeding with all of the necessary development to turn that into a collection capability. So what they were asking from their customers during those presentations was to familiarize themselves with the appropriate search criteria, which unfortunately was redacted, so we cannot be certain for which system they were referring to. Most likely it was the XG score. The second point was to request to get an account to the Bleaking Query program. That was the VPN exploitation team's web application that all of the NSA SIGINT analysts could use to get access to those capabilities. And thirdly, that if any of those analysts found any VPN-related data to inform the VPN exploitation team, and those could be the existence of a VPN on a network of interest and/or configuration setup information about the VPN. Next, the presentation is going to more detail on that Bleaking Query VPN exploitation tool that this team was providing to the entire SIGINT community of the NSA. As we're reading, this tool was a database of all of the metadata of potentially exploitable VPNs. Basically, any VPN that this team was able to identify anywhere on the internet that they could intercept, it was available there so that the SIGINT analysts could quickly see if they could get access to something related to their targets. Then we're reading the three data sources that this program had. The first one was the ToyGrip metadata testing. ToyGrip was an NSA data store of VPN endpoints that it was used by targeting officers to determine if that computer should be a target for further exploitation. The XG score was, and likely still is, one of the main tools that the NSA SIGINT analysts were using on their day-to-day work. In summary, analysts were creating what is mentioned as fingerprints, which you can think of it as queries, and if anything matched those queries in all of the NSA's collection, it was letting them know that they have a hit and they can look into that. So XG score fingerprints was another data source. And the third one was the daily operations of that team, the daily VPN exploitation. Anything new that they were doing or developing was also available in the Bleaking Query. Now, something being in that system doesn't necessarily mean that it is immediately exploitable. It means that it is likely exploitable, and this is why the team was highlighting that, let us stress, potential. If a SIGINT analyst want to get access to that system, they wanted an account basically, they could reach out to the email addresses that were redacted from this slide deck. And following that, we have a look at the program itself. Here is a redacted screenshot of the Bleaking Query. As you see, it was a web-based application, but let's have a closer look. On the left side, we have the search criteria. And as you see, we have three different tabs. We have the simple search, the advanced search, and the batch search. Here we see the options of the advanced search, where the analyst could enter details like IP addresses, or SIGAT, the SIGINT activity designator, maybe case notation, country, 5 eyes defeat, and we will get back to that, city, domain, company, modem comment, target name, status, VPN type, last seen, and so on. Based on those criteria, there will be a list of results in the main part of the page. Here it is redacted, but what we see is that from left to right we have the classification, the status, IP addresses, the city, company, domain for one side of the VPN connection, and then the same for the other side of the VPN connection. Then on the top right, we have 3 more options, which is to turn off the network knowledge base links, to view the versions, and to ask for help. On the bottom of this one, we have some basic documentation to help the analysts understand what they are seeing. As we're reading, Blinking Query or BI documentation is moving to Blinking Query's wiki info page so that it's easier to maintain. This panel will continue to show status codes. If you remember, in the main listing, it started by classification and then status. This is what those status codes here explain. 0 meant potentially exploitable, which means the VPN exploitation team could get access to one of the 2 sides. 1, potentially exploitable, missing password. 2, potentially exploitable, but attack failed. Number 3, potentially exploitable. Number 4, no password required. And number 5 and 6 are confirmed exploitable, either by no payload was decrypted or with 6, payload successfully decrypted. The redacted part was referring to the different diagraphs that the tool was using to refer to different countries, like CN for China, for example. And if you remember, in the advanced search, there was an option for 5 eyes defeat. As we're reading, the 5 eyes defeat option is only available via the advanced search query. For defeating all 5 eyes results, place Y in the 5 eyes defeat box. Any other characters will not defeat 5 eyes results. And on the top that we had the button to turn on or off the NKB links, we are reading that this button toggles on and off the NKB lookup capability for IPs. When you click on this button, the last query will be automatically rerun. Disabling the links makes it easier to highlight and select, double-click, the individual IP for pasting in another document. So this is how the analysts could use this VPN exploitation tool. And next, the team was showing us how they process different VPN technologies, starting with IPsec processing. Starting from left to right, we have the scissors, which is the system that processes passively collected SIGINT traffic, and mail order, which was a file transport system at the NSA. Those are going to filter IPsec traffic and store it in a data store called Vulkan DeathCrypt. This will have the actual IPsec VPN collected traffic. Then the generic IPsec wrapper.pl refers to a script written in the Perl programming language that's going to access this data store and use specific attack scripts to extract the pre-shared keys or PSKs, where this is possible. Those that were successfully extracted, they will be stored in the Coral Reef data store. Then the same script is also going to feed into the Turtle Power, a system that was processing VoIP communication data and had automated decryption capabilities. And out of that, the results will go into the Pinwhale, the primary storage, search and retrieval system for SIGINT text intercepts, as well as XGScore that we already talked about. Now after that, the VPN exploitation team, in their presentation, they were going through the 4 types of VPN technologies that they were experts at, starting with IPsec. On the first bullet points, we have some technical specifications. For instance, that IPsec stands for IP security. It is a complete paired internet key exchange with the common UDP ports being used being 500 and 4500, that it is using pre-shared keys, and also that if you get access to router's configuration, it is a good source to extract those pre-shared keys, that it supports encrypted payloads with either encapsulating security payload ESP or authentication headers AH, and those are indicated by the next protocol 50 or 51, and that the XGScore has queries for IPsec from the VPN exploitation team, along with full DNI, and you can refer to a presentation we have shared in the past about DNI, Digital Network Intelligence, for searches. And on the third bullet point, we have the exact XGScore fingerprints that a SIGINT analyst could use to filter that traffic. For instance, they could have filter based on a country or an email address, as well as app IDs and fingerprints like the ones you see here, so that they only filter on IPsec traffic. For instance, the first one, VPN/star, is going to catch all VPN traffic. The second one, VPN/ESP, is only going to capture traffic that is using VPN with encapsulating security payload. The third one, VPN ISA-KMP, is only going to capture traffic using the Internet Security Association and Key Management Protocol, and so on. The second type was the PPTP, or point-to-point tunneling protocol. We can see that if the next protocol number was 47, it meant that it was carrying PPTP payload, and if they saw TCP port 1723, it meant that PPTP tunnel was set up but there was no payload. For this protocol, the VPN exploitation team was offering one-sided collection, the client side specifically, and for XGScore, they were still providing full log DNI search, and they could use XGScore by adding the IP addresses, case number, etc. of interest, along with the AppID/fingerprint VPN/PPTP_N*, which means anything starting with that. And they also recommend to share the results with a redacted contact from the VPN exploitation team. Type 3 was referring to SSL, or Secure Sockets Layer, which was officially renamed to TLS, Transport Layer Security, in 1999, but still both terms were used interchangeably at this point. The team was offering paired collect, comparing IPs and ports, along with server certificates that were available in plaintext, and the target port numbers were the ones that you see here. For XGScore queries, once again there was full log DNI search, but also a dedicated SSL plugin. As we're reading, there was the AppID fingerprint encryption/SSL or network_encryption/SSL that was filtering only the SSL traffic. And the last type supported was the SSH, the Secure Shell. As we're reading, it was an industry standard networking protocol for securely logging into other machines via network. The VPN exploitation team was offering complete paired traffic by filtering into port number 22, and they were able to potentially recover usernames and passwords useful to tailored access operations to access boxes and gather cryptographic information. Basically, the VPN exploitation team might be able to get the credentials, and then they could give them to the NSA hackers, the Tau team, and they could log into those systems using their tools and extract cryptographic information which could be fed back to the VPN exploitation team so that they can decrypt the full traffic. In terms of XGScore queries, it was still having full log DNI search with a fingerprint terminal/SSH/*. Now, getting a little bit further from the technical side, who were the main customers of the VPN exploitation team at that time? They were receiving VPN-related requests from across the globe, from the NSA's Targeting Office of Primary Interest, the Signals Development Analysts, the Office of Target Pursuit Analysts, different cryptologic centers, field sites, as well as second parties. And what kind of requests they were receiving? The many flavors of requests were including VPN metadata, creating accounts to the VPN exploitation tool that was demonstrated earlier, the blinking query, analysis of network protocols, finding out interesting terms and names, evaluating systems for vulnerabilities, analysis of domain names, creating XGScore fingerprints, router information which could be used for SIGINT development, of course IPsec, PPTP, SSL and SSH exploitation, and details about Internet Protocol links and ranges. And following that, we have the exact steps that were used for anyone that wanted to make a request to that team. The first was that an analyst came across some VPN information and they have a question. They are going to reach out to the VPN exploitation team through a contact that was redacted in this presentation, and this is going to be assigned as a task to a team analyst. That analyst is going to gather background information about the request. After this step, we go to consult repositories. The first, of course, is going to be the VPN exploitation team's tool, the blinking query, that's going to provide a metadata database of potentially exploitable VPNs so that they can quickly assess if they can decrypt this traffic or not. As shown earlier, this will be using the ToyGrip, which is a VPN metadata repository, the Pinwhale, which is the long-term repository for tasked SIGINT Collect, the main database that the NSA was using at this point, as well as XGScore that processes databases from DNI Collect from various field sites and looks into both tasked and untasked feed, the Vulkan Death Grip, which has all of the passively collected VPN information, and the Fourscore, which is a dedicated PPTP repository. If this is an IPsec tunnel, there are some additional steps that we're reading here. They are going to format download repository files, create intermediate processing files, check for potential vulnerabilities, search if they already have the pre-shared keys in Coral Reef data store. If not, run attacks to recover the pre-shared keys and use those to decrypt the traffic. The last step of a request process is of course to communicate the results. Can the VPN exploitation team decrypt this traffic? If the answer is no, then they are going to explain how to turn it into a yes. And if the answer was yes, then happy dance. Okay, in this case, everything is good because they can decrypt. Or as they say, we have a decrypt. They are going to notify the customer of the success, send the decrypt through post-processing and deliver to the targeting office of primary interest, have the TOPI determine the priority level of the resulting plaintext, get the IP addresses on sustained collect, which means to continuously collect and decrypt this traffic, and once all of that is working, set up and transition the sustained decryption process to the equivalent Office of Target Pursuit VPN branch representative. What happens, however, if it is a no and they have to turn it into a yes? As we're reading, it depends on why they couldn't decrypt it. The first thing they will try to do is to find the pre-shared keys, locate the complete paired collect, locate both the Internet Key Exchange and the encapsulating security payload, ESP traffic, have their collection sites around the world do surveys for those IP addresses, and find better quality collection with rich metadata. Once they have all of this additional context and details, they are going to reach out to their friends for help. The friends are the network security products that they are developing decryption algorithms, the tailored access operations that they can try to hack into those systems with computer network exploitation operations, as well as the different collection sites the NSA had around the world to see if they can perform surveys for the IPs of interest. If this didn't get the team to decrypt this traffic, they are going to find out more friends. As we're reading here, the NSA CSS or Central Security Service had the Commercial Solutions Center, which was managing industrial relationships. So maybe the NSA cannot do that, but someone in the private sector could do that. Or maybe the SIGDev, the SIGINT developers, could develop some new tool or method to help find the traffic that they desire. Also, the Office of Target Pursuit VPN representatives could assist in locating traffic of interest, and the topic could provide a lot of context around the target. The aim is to go for sustained exploitation. Develop sustained exploitation thread after the topic confirms the decrypts are interesting. TOPI must task the IP address in a system called Cadence. In there they are going to add the task port and IP address, and that's going to be used by the UTT that was described in the PRISM presentation as the Unified Targeting Tool. Of course, it's also to get the crypt system title, and to do that, they will have to work with the Office of Target Pursuit VPN Regional Branch representative. Following that, we have the establishing the data flow. They refer to a specific person that was redacted as the Cryptanalysis and Exploitation Services Data Flow Guru, and they are going to make sure the correct routing tags and categories are appended to the data. Then they are going to direct the task traffic to the correct data repositories, like Pinwhale for most of the collection, Vulkan DeathCrypt for IPsec, Vulkan MindMeld for SSL, Fourscore for PPTP, and they also note that they are trying to avoid relying on XGScore workflows due to legal and logistical issues, as well as that SSH is using XGScore workflows directed to a file directory. After the data flow has been established, the next step is to check its integrity. Evaluate data integrity, quality, and quantity. As we're reading, different collectors produce different metadata formats. The VPN exploitation team needs rich metadata. They need all the pieces. They need to ensure that the data is not garbled and headers are attached properly. They need to check that the data volume is what they expected. And previously they mentioned that they might have to reach out to different NSA collection sites. So in more detail, they are going to contact collection sites if there are data issues such as malformed headers, missing metadata, missing payloads, garbled data, low volume, and single-sided traffic. The collection sites were sometimes only collecting one side of the VPN traffic, but for this decryption, they need both. Once all of those issues have been resolved, the team is going to move to decryption processing. They are going to create the SRI files for the decrypts and send the decrypt and SRI files to the Turtle Power that was mentioned previously for IPsec and PPTP, or to Capri OS for SSL and SSH so that they can do the post-processing. that is, decryption of the payload, decompression, and unrar archived files. Next, they are going to set up the route to appropriate data repositories according to the crypt system title and type of the decrypt, text, voice, etc. At this stage, we are moving to the decryption repositories, with the primary one being the Pinwhale data store, that it is tasked for IPsec, PPTP, and SSL traffic, and must be placed in the correct partition according to the classification. For instance, release to Five Eyes, no foreign nations, FISA, etc. For XGScore and specifically SSH, they often have router configurations and user credentials which are easier to view in XGScore than Pinwhale, but this was still in the developing process in 2010. Once all of that was done, the TOPI, the Targeting Office of Primary Interest, was going to do an evaluation. The analyst is going to locate the decrypts in Pinwhale and or XGScore, view the decrypts on Pinwhale, XGScore, Agility, and DNI Presenter. They are going to contact the Turtle Power or Capri OS if there are any rendering issues, and also try the Unidentified Protocols team in the SIGINT, which is the S31122, for help in identifying unknown protocols. Assuming that everything went well and now there is a sustained collection of that VPN traffic, we're moving to the thread monitoring. As we're reading, responsibility for monitoring these exploitation threads are transferred to the Office of Target Pursuit VPN Regional Branch Representative. After the thread is established and stabilized, troubleshoots decryption and collection issues, they are going to set up a scheduled task known as a cron job to run the decryptor every day, and hopefully the TOPI will continue to identify and report mission-critical intelligence from these decrypts. And now we have some quick success stories, starting with IPsec. That goes for FTM, or Follow the Money, and Tau targets. The TOPI has had a close relationship with Tau for quite some time, and they had a Follow the Money target 1, which unfortunately for the NSA, the target was not susceptible to any of the NSP's implants, that is, backdoors. So the tailored access operations got the configuration files which provided us with a pre-shared keys and enabled passive exploitation. Then, a Follow the Money target number 2. The tailored access operation got on the router through which branching traffic of interest flows. And remember that this was about follow the money, so they were looking to financial transactions for this specific target. So the NSP had an implant which allowed passive exploitation with just encapsulating security payload, and that led to successful exploitation for the past 2 years. The second success story is related to spying on airlines like Iran Air, Royal Jordanian Air, and Transaero Airlines, as well as communications like the Russian Mir Telematiki and the Afghani WiMAX, and government organizations like Mexican Diplomatic Traffic, Pakistani General Intelligence, Turkish Diplomatic Traffic, and the Afghanistan government. All of them were using PPTP to secure their communications. And continuing to the next slide, they also got access to banking and financial information, such as the African ZAD Financial Services, where they found e-wallet transactions of a principal financial node for Somali terrorist activities for one of their FTM customers. They also managed to capture traffic from the Kabul Bank of Afghanistan, the BNI Banking of Indonesia, where we are also reading that it was formed and owned by the Indonesian government, and that they were performing banking transactions over Flexi, Telkom Indonesia's fixed wireless network. They got access to an Iranian IRGC cyber attacker, as well as a Nigerian power company's internal network. And those success stories were shared with the SIGINT analysts in this presentation to remind them that if it's not exploitable now, that doesn't mean it won't be later, that they collaborate and communicate with their friends to produce decrypts, and that traffic must be both good quality and the correct type. And with that, we're ending this very unique digital artifact that gives us a glimpse into the world of cyber espionage by one of the most advanced, if not the most advanced, signals intelligence agency of the world. Now, when you're reading the news and you see a new VPN vulnerability getting patched, something that happens on a regular basis, consider for how long this vulnerability could have been known to someone like the NSA's VPN exploitation team. When you are wondering why would someone target a bank or a private company in Nigeria, think again, because we just saw a few practical examples from over a decade ago showing how those could help a spy agency in their intelligence production process. In conclusion, all of those things happen every day 24/7 in the cyber world, but very few know about them and even fewer have the capability to observe them and do something about them, clearly showing how nothing is as it seems.